Okay. The formula for this one is Sn. That's the general formula. Is Sn is equal to the initial amount here is S0, and you have 1 plus R divided by N and T. Since we have here component monthly, N equal to 12, okay? And this is T is the number of year. Okay. Sn is S0 is where S0, okay, just let's skip F0, and you have 1 plus R is 0.03 divided by 12, and you have 12T. And remember the 0.012 was, I think, 1 point something. And Sn here, Sn is just S0 times 1.0025, I think so. And then 12T. Good. 12T. Yeah, 12 to the n. So 12 to the n, don't make it 12 to the n because we have Sn. Or you can say just St is equal to S0, 1.0025, 12T. Let's make it T. Okay, here, check. 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 Okay, let's just make it T here. You have this one. So now the question was find the recurrence relation, and you can go from 1 year, you have S1 is S0, and you have 1.0025 times 2 times 1. For 2 years, you have F0, same thing, 1.0025 number of year 12 times 2, and so on until we reach Sn is S0, and you have 1.0025, and you have 12 times n, 12 times t. Okay, for St plus 1, you have S0, and you have 1.0025, 12. You have 12 times t plus 1. Okay, so now from here you can tell is St plus 1 is just S0, and you have t, and you have 1.0025 times 12t, and you have times 1.00, and you have 25 times 12. Okay. Now check here. Check here. Now from here you can tell here, this one here. This one is nothing than St. Okay? Check St here. St is right here. This one is nothing than this one. Okay? So now you can just say St plus 1 is just 1.0025, 12, and St. That's it. That's the recurrence relation. Okay? That's the recurrence relation. So now the next one is to find if F0 is this one, find the amount deposit for 1 year. Of course, you have just S1 is S0. Remember, is S0 times 1.0025, 12. This is just 1 year. Okay, this is number of year. Remember. So S1 is 1,000, 10,000 times 1.0025, 12. Okay, that's it. So now the APR is just this one. You take the amount 10,000 times 1.0025 minus 10,000 and divide it by 10,000. That's it. Okay. Now the next one, found the volume, not the formula for this one. So you have this one, 3 times n minus 1 plus 3 n minus 2 plus and so on plus 3 square plus 3 times 1. Okay. And this one is the same when you say 3 minus 1 plus 3 n minus 2 plus and so on plus 3, 2. If you multiply and divide by 3 to the n, nothing will change. Same thing, the last one. 3 times, let me check the, okay, here is positive, here is plus. Same thing, if you multiply 3 by, here is 1. 3 times 3 to the n divided by 3, same thing, nothing will change. Same thing here, if you multiply and divide by 3 to the n, nothing will change. Okay. Now we can factorize by 3 to the n. If you factorize by 3 to the n here, we will get 1 over 3. And the next one, we will get plus 1 over 2, no, 3 to the 3 square, plus and so on. If you factorize by 3 to the n, the next one we will get check. If you factorize by 3 to the n here, you will get 1 over 3 to the n minus 2. Be careful here, okay? Here, from here, you will get this one, okay? And the next one from here, you will get, if you factorize by 3 to the n, you will get the next one is 3 to the 3n minus 1, okay? Here, this one is here, okay? Now the next one you will get, check. The next one you will get plus, if you factorize by 3 to the n, you will get 1 over 3 to the n. It's obvious, okay? You keep going. You keep going. Here, okay? Now, this one is just, this one is just 1 factorized by 3 to the n, and you will get here, you will get 1 over 3 is 1 plus 1 over 3, and you have a square plus and so on plus 1 over 3 to the n minus 2 plus 1 over 3 to the n minus 1 plus 1 over 3 to the n. Okay. Here is a geometric series with a radius of 1/3. So here then you will have 3 to the n times. Now remember the formula, go check it, the sum of geometry sequence with a radius of whatever, or. So you will have the first terms is 1 over 3, okay? 1 minus the radius times power, the number of terms is n. The number of terms is n minus 1, no, minus 1 plus 1. The number of terms is n minus 1 plus 1. And here it's just n. That's the number of terms it have to be here, okay, on the top. So then the number of terms is n, divided by 1 minus 1 over 3. And then this one is just 3 to the n times 1 over 3. And then here you flip it here on the top, and then divide it by 2 here. And then check, you will get 3 to the n minus 1. I just do it directly. and then times 3 to the n. Okay, 3 to the n will cancel out. Look at here, 3 to the n will cancel out, 3 cancel out. And then you end up having the final solution is 3 to the n minus 1 divided by 2. That's it. That's all. That's all. Okay? This is your final solution for this one. Okay. The next one. The next one you got a B. Okay? The next one you got a B. Check. The next one you got this one. Okay, you got 2 to the n minus 2 to the n minus 1 plus 2 to the n minus 2 minus 2 to the n minus 3 plus negative 1 to the n minus 1 times 2 plus negative 1 to the n. Okay. Now here, this one is, let's factorize by 2. Let me write it down again. You have 2n minus 2n minus 1 plus 2n minus 2 minus 2n minus 3 by here check negative 1 to the n minus 1 2 times 2 to the n divided by 2 to the n. Okay, here this one, just let me write down the bottom. Okay, you have a positive plus negative 1 to the n times 2 to the n over 2 to the n. Okay, now same tactic. Let's factorize here by 2 to the n. If I factorize by 2 to the n, I have here this one remain. I will have a negative 2. Okay, if I factorize here by 2 to the n, I will have 1 left here, the first one. I will have the first one left if I factorize by 2 to the n. Okay, the next one, if I factorize by 2 to the n, I will have a negative 1 over 2 left. And the next one, I will have a positive 1 over 2 squared left. Factorize, I will have a negative 1 over 2 to the third left, plus so on. Now here, if I factorize by 2 to the n, I will have a negative 1 over n minus 1 divided by 2n minus 1 left. If I factorize by 2 to the n here, I will have plus negative 1 to the n over 2 to the n left. Math is beautiful. And then you will have 2 to the n. You have this one, 1 minus 1 over 2. Now check here. Okay. You will have here 2. Okay, check. Now you will have a negative 1 over 2, 1. Check. Because here, okay, let me point out something here. Here is just 1 over 2, 0, power 0. Any number raised to power 0 equal to 1. Remember that one. This one is just 1. So you keep going here. You have 1 over, you have a negative 2, negative 1 half square. It's just this one. And if you do also the next one, you have plus negative 1 over 2 to the third. Okay? And so on, you will have negative 1 over 2 n minus 1. And plus negative 1 over 2 to the n. You have this one. Okay? So now you have 2 to the n. And then now you can use the geometric sequences by using the summation. And you have the first terms is 1/2, which is just 1, okay? And you have 1 minus, the ratio is 1 over 2, and the number of terms is this one. Check here, the number of terms is this one, the n minus 0 is n minus 0, and plus 1, and the number of terms is n plus 1. And put the n plus 1 here, you have n plus 1, and divide by 1 minus parenthesis negative 1 over 2. Be careful here, be careful, okay? Now check. You have 2n, and then you have this one. And this one, you flip the bottom one on top, you have 2. And you have, be careful here, you have 2 here. Okay, you have 2 plus 1. If you don't know, let me know. Email me if you don't know how did I get here. Because here is just 1 plus 1 over 2. And this one is just 1 is 3 plus 1. Okay, divide by 2. I flip the 2 on the top. That's why I get the 2 here. Okay, and on the bottom, I got 2 here. Be careful, it's 2. It's 2 plus 1 is 3. That's why I get here 3. Here have to be 3. Got it? Okay, let's move on. So here I will get this one. Okay, now here I will get check. I will get 2. Check. I will get this one here. I will get here 1. I will get 1. I will get negative. I will get negative 1/2 times. Okay, let me do it like this. Negative 1/2, and then times negative 1/2 n only. Okay, because if you add them, you get this one. Okay, and then if you want to simplify, you can get this one and 3. Because if you add this one is n plus 1 and divide by 3, and you will get this one. And this one is just check. It's just 2 to the n plus 1. Okay, and check. And check. Yes, and you got this one, and you got check plus 1, plus negative 1 to the n. Okay, and you got this one, and you got 3, and 3 is right here. Okay, you can leave it like that, or you can even stop here. I will give you full point. It's fine. This one is just algebra. You calculate it. Okay, the process is like this. Okay, next you got this one, and they ask you to use the mathematical induction to prove this one. Okay, to use the mathematical induction, you have to prove the base case. In the base case, you can tell if n equal 1, okay, of n equals 0, whatever, you will get it. How did you figure out if n equal 1? The base case. Base case, if n equal 1, for example, you have 2 times negative 1. 2 times negative 1 is negative 14. Okay. Okay. Next, if n equal 1, you got this one. So now you have, if n equal 1 on this side, you got a 1 minus negative 7n plus 1 divided by 4. If n equal 1, you have this one 1, and you have 1 minus parenthesis negative 7 to the square. Okay, and you have 4. What you got here? You got a square is 1 minus 7 times 7 is what? I know 7 times 7 is what? I don't know. 7 times 6, I don't know. 7 times 5, I know is 35. 35, I would have to add 7. And if I add 7 is 42. Okay, if I had 7 also, it will be 49. Then 7 times 7 is 49. Anytime you forget, that's the process, okay? 7 times 7 is 49 then. 49, okay? Now, 49 over 4. Now check here. Now check. Now you have negative 48 over 4. And negative 48 over 4, you can tell is negative this one is what? 48 over 4. You have 1 is 0, 8 is 2, and you have 12. So why I get this one here? The base case. Why I get this one? Is 1. Oh, here is 1. If n is 1, sorry. If n is 1, you have 14. Okay? The base case here, I don't know why I get 12, but the base case is fine. Why I get 12? Why I get 12? How did I get 12? How did I get 12? 49. 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 How did I get 12? I don't know. Okay, here is 49 tone, 49. I had 48. 48. Okay, check it out. Okay. Okay, let me change the base case. Stress me out. Okay, base case if n equals 0, if n equals 1, if n equals 0, if n equals 0, 8, 2. Okay. Okay, just let's, I don't know why I didn't get this one. If n equals 0, so I get here is 2 times negative 7, 0, I got 2. I may just make a mistake previous one. And here, the second one, I have 1 minus parenthesis negative 7 and plus 1 divided by 4, okay? Now, if n equals 0, I got this one. I got 1 minus 7 minus is positive here, positive 7 divided by 4. And you got 8 over 4 is just 2, okay? Now, this one equal to this one is a fact, the base case. Now, the next one is to prove, suppose this one is true. Suppose 2 minus 2, 7 plus 2 times 7 squared plus negative and so on plus 2 parenthesis negative 7 to the n is true. Equal to 1 minus parenthesis negative 7 n plus 1 over 4 is true. Okay? Your goal is to prove this one. Goal is to prove 2 minus 2 times 7 plus 2 times 7 square, and you keep going, plus 2 times negative 7 to the n plus 1 is equal to 1 minus parenthesis negative 7 n plus 2 divided by 4. Okay, this is your goal. So now you know here the before the expression we have 2. Here is that is 2 minus 7 to the n. Okay, now from here 2 minus 2 times 7 plus 2 times 7 square, and you keep going, you have 2 minus 7 to the n, okay, plus 2 times negative 7 to the n plus 1. And this one, if you check here, since we suppose by assumption this one is true, okay, if this one is true, then we can replace it from here, and then we end up having 2. We end up having this one. If you replace it here, you will have this one. You will have 1 minus parenthesis negative 7 to the n plus 1 over 4, and plus that one, okay? Plus 2 parenthesis negative 7 to the n. Okay. So now check. You have 1 minus parenthesis negative 7 to the n plus 1 divided everything, because we have to reduce the same denominator. You have 8 negative 7 to the n divided by 4. Check here. Okay, so now here we will have 1 minus negative 7 parenthesis n plus 1, and then here check here. check here. Here you have plus 8, negative 7 to the n over 8. So this one is just 1 plus, because here is negative 1 plus 7 over negative 7 to the n. If you don't understand here, let me know. And here is plus negative 7, okay, to the n. And here you will have and here you will have 4. Now here, know something here. I want you to know something. From here you have 7 parentheses negative 7 parentheses negative 7 to the n is just here. Negative parentheses negative 7, okay? And negative 7 to the negative n. And you end up having here, from here you will have 1 minus parentheses negative 7 to the n plus 1, okay? Plus 1 and then plus 8, and you have negative 7. And before that, you can just add them directly and then keep going, and then you end up having the same answer. Let me erase here. Okay, everybody got it, hopefully. And you will get this one. Check here. You get this one. You get this one. Oh, be careful. Here is n plus 1. N plus 1. N plus 1. N plus 1. Okay? So if you keep going here, is 4. If you keep going here, you have 1 minus negative 7. I know I done it in class. You should get it. And then you have plus 7. And you have negative 7 and plus 1. So now you can add them now. If you add them, you have 7, and then you have 1 plus 7, negative 7 to the n plus 1. And then now if you add them here, you have 1 minus parentheses negative 7 to the n plus 1, plus 2, because you change it here to positive. Negative times negative, it will become positive. That's why I did it here. And you will become here. This is your final answer, and this is your goal also. Okay? This was your goal. Very good. Okay. Then the last one before I do problem number 5, this one is, you can tell it's geometry series. I advise you, if you have to do this one, you don't have to look at this one. If they ask you to prove this one, you just say check negative 1 half, and you have j. Now this one, since it's a geometric sequence, and the first number is when g equals 0, any number raised to power 0 equals 1, you have 1 minus negative or 1 half. Now the power is the number of terms. Number of terms here is the last one minus the first one plus 1. The number of terms is n plus 1, okay? N plus 1 here, divide by 1 minus parentheses negative 1 half. Okay, here is just it's just 1 minus negative 1 over 2 to the n plus 1 divided by here 1 plus 1 half. And this one is just a 1 minus 1 negative 1 over 2 to the n plus 1, and divided by here. You have 3, flip the 2 is here, 2. And then here you will have 2 times. Here you will have 1 minus, and then here you will have positive, and it will become negative here 1 half, and you will have a negative 1 half, and then you can have a positive here, or you can just keep the negative 2 here. So you will have on the top negative n plus 1, and on the bottom you have 2n plus 1, okay? And divide everything by 3. Okay. Now here, if you keep going, you will have here 2 times 2 to the n plus 1, n plus negative 1 to the n plus 1 and divided by 3 times 2n plus 1, okay? So here remember is 2 times 2 to the n plus 1 and plus negative 1 to the n plus 1 and divided by 3 times 2n times 2. And you can tell here the 2 will cancel out, okay? The 2 will cancel out and you end up having this one. That's what you need from here. That's what they ask you. That's it. Check it, check it, check it. The 2 will cancel out and you have this one. That's it, okay? Okay, I will do problem number 5.